everybody, I'm Mr. Colbert,
And I'm Mrs. Colbert.
and this is
Lab
Lab Busters. Yeah, we're going to look at energy drinks and how much great stuff they could probably do to your bodies. Before we begin, what do we have to make sure about?
Lab safety.
You're right, lab safety. We got to have, first of all, our goggles. We've got those on. But we need our lab coats. You've got your lab coat. You need 2 arms.
Oh,
Yeah. Okay.
easily remedied. Just poke.
All
It's kind of
right.
like, ooh. Did you see that? Did you ever see, what movie was that? Woo! Never mind.
Before their time.
Oh, my bad.
The next thing is, we got to make sure that we're using
Scientific method.
scientific method.
Oh, man, dude, that's from first semester. Who the heck remembers from first semester?
Anybody remember?
You? Oh, I see a hand.
Me, call me.
Okay, Mr. Colbert, know it all.
Observation. We observe what's going on. And then,
I know.
what?
Crap. First semester, yeah, no,
Right, you have a question about it.
Oh, yeah,
Yeah.
I had a question.
And if you have a question, with a question, you got to come up with an answer. So what's the answer called? A hypothesis.
Oh, hypothesis.
Now, a hypothesis is you've got to be able to test it. Okay? You've got to be able to, I don't know, experiment or observe or something to be able to see if your hypothesis is correct or incorrect.
Okay.
And
sounds
then-
good. Sounds good.
Once you have your experiment, what do you get from that?
A conclusion.
Well, to get a conclusion, what do you have to have? Data.
Oh, I've
Your
got to make
results.
those
Your
darn
results
charts
and your
and graphs and all those
Yeah.
freaking teachers always ask me for, and I don't know whether to use a number 2 or number 4 pencil and centimeters or inches, and yeah, I know those.
Use centimeters.
Uh-oh.
Okay. Don't use inches.
Oh no,
Now,
that's just American. Don't do American in science.
no. Which one are we going to do first?
I think we're going to do the potato experiment.
Oh, can we use Darth Tater?
Look, I am your father. Oh no, you're my father.
Well, we can't use Astro Tater. Huh? Astro Tater.
That's right.
But-
So what we're going to do is go ahead and look at this, and we're going to try and make an electrical circuit with the tater. And ton-ta-ta-ton.
Mr. Potato.
That's right. And this Monster energy drink.
Monster Energy Drink.
I tried to read the back of the label, which is hard through swimming goggles. But I'll give it to Mr. Colbert because I'm dyslexic and you don't want to hear me pronounce these names. And he will read your ingredients of all these cans that we're going to use today.
Ingredients.
Natural flavors. Taurine, sodium citrate. Coloring, Panax ginseng extract. I-carnitine, L-tartrate, caffeine, sorbic acid, preservative, benzoic acid, a preservative, niacinamide, which is vitamin B3, sucralose, salt, glucuronol actone, inositol, guarana extract, pyridoxine, hydrochloride. That almost sounds like something Trump would have you injecting, doesn't it? Okay, and vitamin B6, riboflavin, vitamin B, which is vitamin B2, maltodextrin, and
Vitamin B12. All right.
All right, so from all those ingredients, and caffeine. He left out a whole lot of caffeine.
I said caffeine.
Oh, did you say
I
caffeine?
did say
I've
caffeine.
never heard
I
caffeine.
no
I
way
fell
said
asleep
caffeine.
halfway through this, but it's okay.
That's because you didn't have your monster drink.
No, I didn't, but I won't. I won't because this is terrible for your body. It's kind of produces the Little Wayne syndrome, you know. We don't want the convulsion Little Wayne.
It's going to generate electricity. It can charge up your phone or your iPod or your iPad.
And that's what we're busting. So what he's going to do is going to cut the potato in two, okay? And we're going to take some of this, and I'm going to move this dish. I can see it with my green goggles. Pour plenty of this in here. There it goes. There it goes. And then, ooh, that's what the tongs are for. Holy crap. You never do an experiment without tongs.
Okay.
Now that's got to sit for 30 minutes, so
30
we're going to
minutes.
go on to our other experiments. But
Okay.
hopefully we'll be able to
We're set.
charge our, probably my iPhone with this. And then we're going to discuss, oh my God, electrical circuits. Now, let me tell you a quick story. So I tried to build this wonderful Astros replica trophy that lit up. And so I hot glued all these LED lights, put my 9-volt battery in it, and what happened?
It was cool, but
It blew up.
yeah.
I didn't realize LEDs needed more resistance. Who knew they were the resistor types? But I definitely needed 72 ohms of resistance throughout that circuit. Oh well, had to pull out all my hot glue, redo it.
That's
and
part of Ohm's law, to have resistance for your current. In order to have voltage, you must have the ohms, the resistance,
that's right.
measured in ohms.
See, if I push on him, look it. If I push on him and he doesn't resist, there he goes. But
And
come
that
back.
was just current
You
with
can-
no resistance.
If he had resistance, yeah, that's resistance. Okay, now for our next experiment. Oops, crap. So, we're gonna take this balloon, you see it? And I forgot scissors. Yep, because this is from the kitchen. Pour a little bit of more of the Monster drink. And let me tell you about how much this gets action potentials going. You know you need 70 millivolts of it to make an action.
So about right
Yeah,
here.
you drink a little bit of this, 70s all over your body. Yep, I think so. Yep. Okay. Now the video states if we cut the end of this,
See?
and
Cut
then-
the end of it off.
then put it in the Monster drink. God, that's pretty. Soak it in that. It's supposed to,
I'm gonna do this.
I don't know. The video just was like really quick.
Okay.
So we soak it in that. It's supposed to fix itself. Supposed to, what would you call that?
I would say-
Scientifically.
Fusing together.
Ooh.
Now it's not like nuclear fusion, folks. I know all of y'all know all about that. Nuclear fusion, where an atom, two atoms fuse together, the nuclei fuse together. But no, this is just molecules fusing together. That didn't work good, did it?
No, let's try it one more time. We're going to just leave it in there because remember, this is Lab
Buster!
Right. So they put it on a video on YouTube and we're trying it. We're either going to bust it or say it's okay.
Can't always believe everything you see on those things.
Oh no. Oh no. Parlez-vous français? Not at all. Okay, so I'm going to pick up the camera while Mr. Colbert takes the rest of the energy drink and we're going to try some eggs. Let's see what energy drink and eggs do. And then heat it up.
Heat it up.
I think it's time to throw the eggs in. What do you think, Mr. Colbert?
Well, let's let it heat up just a little bit more.
Yep, I see the bubbles. What are those bubbles? Why does it cause bubbles?
Well, as it heats up, the liquid becomes a what?
A bubble.
A gas.
Oh yeah, stages of matter.
Goes from liquid to gas, and that's what's causing the bubbles.
What's that song? Solid, liquid, gas, and plasma. Solid, liquid, gas, and plasma. Solid, liquid, gas, and plasma. And Bohr's Einstein. Here go the eggs. Let's see. So, the YouTube video we watched said if you cook eggs in an energy drink, then they will
become pliable.
very pliable. What does pliable mean? Uh-oh, it starts with a P and ends with a bowl. What is pliable?
Right. Similar to flexible. Pliable like rubber.
Ah, rubbery eggs. Okay, so if I was talking biology and it was about a chicken, and this chicken all of a sudden, oh my God, what is that egg doing? Doesn't look like the video. Anyway, oh my God, look at all that.
A spatula.
Yeah, I'm not too sure about pliable.
It makes it big.
I'm not sure what, I think it's a chemical reaction. So it was supposed to get rubbery, but it seems so. Describe that scientifically, please.
I don't know. I gotta see what happens with this as it keeps going.
It smells good though. Yeah, I'm not sure what happened to the eggs. They were supposed to be rubber. Maybe we put too much energy drink in. Well, wait. We're going to start over and just put a little bit in because this isn't how it's supposed to happen. Take two.
You're out of it.
Okay, so we took the eggs out. Here's what they look like. I'm not too sure about that video to make them rubbery, although we're going to let them cool off because maybe he let them cool off. But I could say this video was
busted.
Yeah. Lab Busters. I ain't afraid of no labs.
Who you gonna call?
Lab Busters.
Yeah.
So here we back at our lab table, and we're going back to the balloon experiment. We waited longer. I guess it's been about 37 minutes. And let's see what happens. First, holy crap! Look at that. Look at that. Did it fuse? Oh, that's a terrible sound. Terrible sound. Okay, quit playing with the balloon. So, was that fusion
I don't know.
or fission?
But it was fission to get it started because we divided the two parts, and then it was fused back together. It was fusion. Not nuclear, but fusion.
I know, right? We don't need any Chernobyl in my kitchen. Heck no.
No.
Okay, so we're going to go back and we're going to try one more lab before we hit our, dun. Darth Tater and the Taters.
Yes.
Oh my gosh, circuits. You ever see Short Circuit? That was a cute movie. Anyway, hopefully we're not going to have a short circuit. And there's our lab assistant, Milo.
Okay, here we go. We're going to have a hammer here. See? Real hammer.
Real hammer. If I have a hammer,
I'd hammer in the morning, hammer in the evening,
all over this land.
And
Okay.
here we go. We're going to pour this energy drink.
He used two of them.
Okay, and then added a little white vinegar.
I know, right? Is there anything else but white vinegar? Can there be chartreuse vinegar?
There can be apple cider vinegar.
Now, so vinegar can be a solvent, not like the universal solvent. Oh my gosh, what's the universal solvent?
Would that be water?
Oh, that would be water, and I think that's part of
Alright.
chemistry this week. So, if you had water, you know, that's really polar. Not bipolar, but polar. Well, it kind of is bipolar. It has
No,
the...
I'm really
the-
thoroughly disappointed because this one is also busted.
It's not busted yet. He took time with it.
It didn't take much time.
He didn't, but it was a video. Okay, we're gonna keep doing this, and tell me about the polarity of water.
Well, water has two elements in it. What are they?
Well, I think, it's high quality H2O. Ooh.
High quality H2O, which would be hydrogen and oxygen. And so you have one atom of oxygen, two atoms of hydrogen. And so you have the hydrogen, which they're going to be in a covalent bond.
Ooh, covalent.
What does that mean?
Ooh. I think covalent, they share things.
They share the valence electron.
Oh,
That's
not
why it's
valence.
called covalent. What is a valence electron?
Oh, the one in the outer shell. I know
All
that.
right, nice,
Woo!
nice. So they're sharing their outer electrons, their valence electrons. That's why it's called covalent. But
Holy crap.
they don't share them totally equally
Oh,
because
no.
oxygen has 6 electrons, 6 valence electrons. Hydrogen only has 1. So it's a little bit stronger than the hydrogen. So instead of just sharing all the time, oxygen's like the big brother sharing with the little brother. Okay, you can play with it. Okay, now give it back. And so they're sharing those valence electrons, but oxygen keeps it most of the time, which causes the hydrogen to have a little bit of a positive charge.
Oh, no.
Oxygen, having the electrons more often, has a negative charge.
Oh, no.
And so that's where bipolar comes from. Hydrogen's positive, oxygen's negative. And so you have that with all the other water molecules. They all have the same thing. Hydrogen being positive, oxygen being negative. What happens with negatives and positives? They attract. And so you have that being attracted. And so when you put things into water, they pull, the positive pulls on the negative, negative pulls on the positive. That's why they pull things apart. That's why it becomes the universal solvent you mentioned earlier.
Okay. Woo!
All right.
So, in this experiment, when you put the two together, you were supposed to roll up this hammer. Yeah, I don't think so. Yep,
Ain't happening.
ain't happening. So far, we've only had the balloon work, the eggs, no mo gusto. No mo gusto. Or me gusto. I think it's me gusto. Yeah, okay. Yep, Just keep swimming, just keep swimming. I speak well.
Yeah.
Never mind. Okay, so now we're going to go to our last experiment, and that's to see if this potato in an energy drink can actually turn on the charge on my iPhone. And let's talk about circuits.
Well, okay. Well,
Do you want to be parallel or do you want to be like in a series?
Well, we don't want to do. I don't think we can do parallel from a potato, because parallel is going to be multiple circuits going in multiple directions. Whereas a series just means it goes from one to the next one to the next one. And if you turn it off, it turns the entire thing off.
And I don't know what's going to happen. I'm going to walk over. It said it had to wait a minute because, again, we're busting videos on the internet. Lab videos. Don't be unscientific and cheat. Gonna plug it in and see if I get my
It
little.
says it's charging.
It turned on. I don't know. So, what's it say? Is there a little charge signal on there? I can't see. Oh, crap. There it goes. Well,
It make no sense, yeah. It make no sense, no. It make no sense, yeah. Make no sense, make no sense, no. Make no sense.
well, I think we're like 50-50 on experiments. The balloon worked and the
charger
potato
worked.
worked. But the hammer, yeah, it's still.
That was totally fake.
Yeah, and we're not even going to walk over to the mess that we started in the kitchen for the eggs that were supposed to be pliable.
They were not pliable.
No.
They fell apart.
I'm still wondering, okay, back to diversity, natural selection, if every chicken started laying rubber eggs that nobody would eat, would that be, like, isn't that advantageous?
That would be natural selection, where it would not have its eggs eaten. It would be having more chickens.
That's right, but if there were more chickens, what populations would it change?
Well,
What you talking about, Willis? Why are you talking about chickens?
Other populations somewhere?
what populations would chickens change?
Say we were overrun by chickens.
What you talking about? What do chickens have to do with biodiversity? Chickens are in the hen house.
So, chickens eat what? What do chickens eat?
Seed, worms.
Okay, well, chickens eat seeds and worms. Would plants grow? Would worms still be around? Oh my God, what would happen to my garden?
What you talking about, Willis? I don't know anything about no chicken.
Be eating it all up.
Well, yeah, or just eating the little creatures that keep my garden safe. Now, who eats chickens?
What's this fixation you have about chickens?
Other than humans, what natural thing?
All predators.
Chickens.
Well,
Would there be more
No,
food for
I
other
guess-
species?
foxes, because that's who you're always trying to keep out of the hen house.
Okay, so all of a sudden, holy crud, if the chickens population was up, would the foxes population be up? They have more food in the food chain.
Yeah, there'd be a lot more foxes. No eggs, but a lot more
That's-
foxes, a lot more chickens.
So here you go, chicken. Next time you're talking to a chicken, tell them to lay a rubber egg.
Well, that'd be advantageous, but it wouldn't do much for the biodiversity.
Oh, so a rubber
Because you're
egg wouldn't
talking
be...
about just having lots of chickens out there, whereas biodiversity counts on being a lot of different species.
Okay, so I need the rubber egg to turn into what?
Normal egg.
Oh no. Then we went back. That doesn't work. But it's kind of like what? You know, the pepper fly moth. You know, the one that was in England back in during the industrial times. You know that
Yeah.
pepper fly moth. You know, and how they were all white thing, but all of a
And
sudden,
the birch trees were all white bark, and so they blended in, and so it was hard for the birds to find them to eat them. But then Industrial Revolution came along
right?
and put soot all over the bark of the trees, and so the trees became dark. So the white moths were the ones that stood out, whereas the dark moths that before were the ones that stood out on the white bark. Now the white moths were getting picked off by the jays because they were easy to spot. The dark moths, they were the ones reproducing and living because they weren't spotted by the birds.
I know, right? So, moral of the story, be peppered. You got to mix because you won't be eaten. Anyway, so to end today's segment, and hopefully we'll have more that, good. Although, don't drink this. This is crap. Alright? You'll get seizures and everything else. It's not good. But, here we are. Have a good day.